This is lesson 10-5. It's the last lesson in topic 10. We're going to be working with ratios as decimals. Start off again with the launch problem. Just try your absolute hardest and we'll go over the answer shortly.
Two students take turns recording daily rain totals. When the teacher sees their work, she exclaims, "Give me the daily results and total rainfall in one way." Show how you would revise the results for the teacher. Then explain your work.
What they did for the answer is they turned all of these fractions into decimals, and they found out the total amount of rainfall that happened throughout the week. So they added 1/2, 2/10, they added 3/10 inch from Tuesday and also 6/10 of an inch. So the work that they showed is right here, and they got a total of 1.6 or 1 6/10 inches total rainfall.
To write a ratio as a decimal, first write the ratio as a fraction. Then write the fraction as a decimal. 1 to 2 written as a fraction is 1/2. 1/2 written as a decimal is 5/10. A ratio written as a decimal is a comparison of the decimal to 1. 5/10 means 5/10 to 1.
So again, we're taking what we know about ratios and writing them as a fraction, and then we're taking what we know about fractions. We can divide top number divided by bottom number and get a decimal point. So again, this decimal is showing you a comparison to 1.
The aspect ratio of an image is the ratio of the width of the image to the height of the image. The table shows the aspect ratios for 3 computer monitor settings. Complete the table.
So what I see is that the aspect ratio is 4 to 3. It wants us to write this ratio right here as a fraction. So the first number is our top number, 4 over 3. Second number is our bottom number. And in order to find the decimal, we have to divide 4 divided by 3. We know that 3 can go into 4 one time. That is 3. And there's 1 left over. We would have to add our decimal point, add a 0 and drop it. How many times does 3 go into 10? It goes in 3 times. So 10 minus 9, because 3 times 3 is 9, is 1. I can add a 0 and drop it. 3 can go into 10 3 times, which is 9. Subtract, I'm left with 1. What I get when I do this is a repeating decimal. I'm always going to get a remainder of 1. I'm always going to add a 0 and drop it, and 3 can always go into 10 3 times, which gives us 9. It will give us the same problem over and over and over again. So I'm going to stop right here, and I'm going to put a line over this just to show that it's repeating. So my decimal is going to be 1.33 repeating. My next problem is 16 to 9. So again, top number comes first. 16 is my top number. 9 is my bottom number because bottom number comes second. And what I have to do now is divide out 16 divided by 9. What I want you to do is I want you to find not only the decimal point for this answer, but I also will be asking, how do I write 5 to 4 as a fraction? And how do I write 5 to 4 as a ratio in decimal form? When you write out 16 to 9 as a decimal, you get 1.78. That's a rounded number. When I scroll down, here is the division problem. They did 16 divided by 9. They had a bunch of 7s, and so what they did was they rounded to the nearest hundredth. My next one, ratio of 5 to 4, means 5 is on top, 4 is on bottom, and when you divide it out, 5 divided by 4 gives you 1 25/100. If you need to pause the video and look through those steps and follow along to make sure that you understand it, feel free. Otherwise, I'm going to move on to the got it problem.
Write the ratio 3 to 8 as a fraction and a decimal.
The correct answer is D, 3 to 8. 3 goes on top, 8 goes on bottom. If you divide those, 3 divided by 8, you get 375 thousandths. I skipped over the part 2 example problem, so if you're following along in the book, just know that I did not do that question, and I went straight to the got it problem for part 2.
The ratio of the number of 6th graders to the total number of students at a school is 45 hundredths. Write the ratio 45 hundredths as a fraction in simplest form.
The correct answer is B, 9/20. I know this because 45 hundredths, that's how you say it as a decimal. That's also how you write it as a fraction, 45 over 100. 45 and 100 are both divisible by 5. 45 divided by 5 equals 9, which is how I get this top number. And 100 divided by 5 is 20, which is how I got my bottom number. So the answer again is B, 9 to 20.
In baseball, a player's batting average is the ratio of the number of hits to the number of at-bats. To find a batting average, divide the number of hits by the number of at-bats. A new player's batting average is 350. The player has 60 at-bats. How many hits does the player have?
So what we need to do is we need to solve this problem. Our player's batting average equals 35 hundredths. And we know to get that, you had the number of hits and the number of at-bats. So it says, new player's batting average is 35 hundredths. Batting average, player's batting average. Right now I'm just filling in the numbers to my equation, which is how I knew this number goes here. My next is the fraction or the division problem. Number of hits I do not know, and the number of at-bats, so at-bats is 60. So I know that I need to make 35 hundredths equivalent to a ratio of something over 60. What we can do with this is we can change this to finding equivalent fractions. I know that I can write 35 hundredths as a fraction rather than as a decimal, and I do that by writing it out just like I say it. 35 hundredths means 35 over 100. And that's going to equal something over 60. I cannot divide 100 by anything to get 60, so one thing that would be helpful is if I simplified this fraction. They are both divisible by 5. 35 divided by 5 is 7. 100 divided by 5 is 20. So now I know that 7 over 20 is going to be equivalent to something over 60. 20 times 3 is 60. 7 times 3 is 21. So how many hits does the player have? 21 hits. Here's the got it problem. Luna.
Another player's batting average is 290. The player has 200 at-bats. How many hits does the player have?
The correct answer is B, 58 hits. This is how you get the solution. You can pause the video and read through this. And here's the last got it problem.
Which player has the best batting average? Explain how you found your answer.
Here's the correct answer. Player 1 and 3 both have a .275 batting average, greater than player 2's batting average, so players 1 and 3 have the best batting averages. That's all for topic 10-5. Make sure that you watch the video, complete your notes, and we'll go over questions in class together.